Hello everyone, and welcome to lesson 2.3 on something called synthetic division. Just to get us started, we're going to take a look at a problem where we want to try and factor a polynomial fully. So factoring a polynomial into as many factors as we can find. When we've done division in the past, we've looked at, or yesterday we looked at, integral zero theorem as a method for finding the proper test factors to try on this polynomial. And integral zero theorem tells us to test factors of 6, so we'd be looking at testing the numbers plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those would be our test factors. So a good strategy to use is to start with the smallest number. So I'm going to start with the number positive 1, and I'm going to evaluate this polynomial at 1. So I'm plugging in 1 for all the variables and evaluating, and I end up with a value of -8. So what this means is if I divide this polynomial by a binomial of x minus 1, I would have a remainder of -8. So obviously x minus 1 isn't a factor of this polynomial, so let's try a second test. Let's try evaluating this polynomial at 2. I plug 2 in for my variables. And this time, I end up with a value of 0 when I evaluate this polynomial at 2, which tells me that the binomial x minus 2 is a factor. So now, based on what we've done in the past, is we would set up our long division and we would divide. If we use long division, it's going to take us at least 8 steps. And if we think about expanding this into a polynomial that has a degree 5 or degree 6, this would take us even longer. So long division is pretty time consuming for higher degree polynomials. Which is why today I'd like to introduce something called synthetic division. Synthetic division is just a shortcut for our long division. So there's my original polynomial. To use our synthetic division, I'm going to set up a little chart like this, and my first step is to write only the coefficients in the top line of this chart. So I've written down my coefficients there. I also will place the test factor, x minus 2, along the left-hand side of the chart. And then just to remind myself, I'm going to put a negative sign there, just to remind myself that I'm subtracting. So my first step now, once I've set up my synthetic division chart, is to carry down the first number. So I bring down the number 1. And then I multiply 1 by -2. So 1 times -2 is -2. And I take that number and I write it underneath the next row my table. And then I subtract. 2 take away negative 2 becomes positive 4. And I multiply that number by negative 2. 4 times negative 2 is negative 8. And then I subtract down the column. Negative 5 take away negative 8 is positive 3. 3 times negative 2 is negative 6. Negative 6 take away negative 6 is 0. And then I'm done. So what happens, or what this becomes, is my factored form, or one step in my factoring of my original polynomial. To figure out the result, I look at the numbers in the bottom row of my column, the bottom rows of my table, and those numbers represent the coefficients of my terms. As well, when I'm dividing, I'm decreasing the degree of my polynomial by 1. So my original polynomial was degree 3. My polynomial, once I divide, would be degree 2. So the coefficient of my first term is 1 plus 4x plus 3. Let's try one more example. I'd like to divide this polynomial by a polynomial of x minus 2. So I start by setting up my table and writing all the coefficients of my terms in the top line of the table. And if I look at this polynomial, I'm skipping from a degree 4 term to a degree 2 term. So I need to include a placeholder . I bring down my first term, multiply it by negative 2, and then I subtract. 0 take away negative 2 becomes positive 2. I multiply. 2 times negative 2 is negative 4. I subtract. 3 take away negative 4 is positive 1. 1 times negative 2 is negative 2. And then I subtract again. And I continue multiplying and subtracting until I have no more numbers in my table. Finally, 2 take away 6 becomes negative 4. If we compare this to the last question we did, the very last number in our table was 0. This time we ended up with a number there of negative 4. This number, the very last number in your table, represents a remainder. And our answer was, looking at our coefficients, x cubed plus 2x squared plus x minus 3 plus a remainder of negative 4 over our divisor x minus 2. Again, notice how these numbers in our table become the coefficients in our answer. Okay, so if you're interested in trying some practice before coming to class, take a look in your textbook or online at page 102, questions 4AC and 5AC. Now that I've shown you synthetic division, feel free to use it whenever you'd like. I will talk a little bit more about it in class tomorrow. Thanks for watching.